is doomed. A devastating force is coming, and we're running out of time. As civilization crumbles around us and our planet is destroyed, can we build spacecraft to take us to new, habitable worlds? Can humankind escape annihilation? Can we evacuate Earth?
It seems like science fiction. The end of the world, no going back, we have to escape, we have to evacuate Earth. But it's really impossible to say that it will never happen.
We have this view of stability on the planet Earth because it's existed for several billions of years, and we've evolved on a reasonably stable environment.
We have small catastrophes all the time, like hurricanes, tornadoes, earthquakes, but in general, the human population continues to grow. This gives us perhaps a false impression about the future.
별 보는 거 좋아하지?
아빠, 여기?
그래. 여기. 잠시 한번 볼래? 잘 보이니?
All of human life, human civilization, and all the other life on this planet really exists in a tiny, precarious shell on this rocky object going around a star in the middle of a big and lonely galaxy.
Is that a shooting star?
Oh, wow, yeah, look at that one.
The ups and downs that we've experienced as a species are nothing compared to what the universe can throw at us. Now, there's a whole list of bad things that can happen to a planet like the Earth.
¿Eso está pasando ahora?
Sí.
Vamos.
There are scenarios where our planet, the Earth, could be completely destroyed.
¡Abran el domo! ¡Abran el domo! Oh my God.
Get in the trunk. Get in the trunk. Get in the trunk.
Reports out of cities from Tucson, Arizona to Okayama, Japan describe meteors the size of bowling balls raining down untold destruction.
Authorities estimate the death toll at 250,000 and rising. This could be the worst natural disaster the world has ever known.
Some leading scientists are now suggesting this deadly event may only be the tip of the iceberg, a signal that the destruction of our world is rapidly approaching.
If we were suddenly bombarded with a shower of large objects from space, that would be catastrophic for Earth, and it would mean many different things, but none of them are good.
Now, there are objects out in the universe that would make the Earth utterly uninhabitable or possibly destroy it forever. These objects could fling comets and asteroids towards us well before they actually reach anywhere close to where we are. So based on all of these unprecedented meteor showers, we would then turn our telescopes in that direction and look intensely to see what was there. We might begin to see, for example, a rogue object from somewhere else, from intergalactic space. One of the most extreme possibilities we can think of would involve an object that we call a neutron star.
A neutron star is a stellar corpse. A star much more massive than the Sun burns through its fuel extremely rapidly. And at the end of its life, when it runs out of fuel, the entire core of the star simply collapses.
This creates one type of supernova in a massive stellar explosion.
But what's left behind is this incredibly dense core made of neutrons. It's something like 10 kilometers across.
Because a neutron star is the mass of 2 or 3 suns, its gravitational pull is enormously strong. And that means that as objects get closer to it, they're subject to enormously powerful forces that can tear them apart.
The other really scary thing about a neutron star is that when it collapses on itself, it can shoot itself off into space at a very high velocity.
It can actually be sent hurtling through space at incredible speeds. So beware anything that gets in its path.
As the neutron star nears our solar system, its intense gravitational field will disturb the orbits of objects like asteroids, and some of that material may arrive as a deadly hail of meteorites right here.
What would happen next? The first thing that the scientists would do is to try to model potential scenarios for the path of this thing into our solar system.
If we determine that a neutron star was really headed in our direction, that's very bad news. You can't blow it up, you can't change its direction, you can get out of its way, or you can suffer the horrendous consequences of being destroyed by a neutron star.
Some scientists are calling it the end of the world.
It's called a neutron star, and astronomers think it's on a collision course with Earth.
If you're just joining us, we're talking with the University of Oklahoma astrophysicist Lawrence Kellogg. Dr. Kellogg, this whole scenario sounds like something out of a movie.
Yes, I suppose it does, but I assure you it's real.
Probably the first public response to a report that there was a doomsday device heading towards Earth is people would think, oh, well, Spielberg's making a new movie. This is probably some kind of gimmick he's doing to get everybody interested.
Where does this neutron star come from?
Some 60,000 years ago, a star at the edge of our galaxy collapsed in a huge explosion. We call it a supernova. Now, the violence of this event catapulted the dead remnants on a journey of thousands of years. Along its way, it is causing cataclysmic damage to anything it encounters.
One of the problems with our current age, which can be a good thing depending upon what the issue is or a bad thing, is that people are very cynical. We don't particularly believe what we see and hear. And you can imagine you'd have various people, various scientists get on the talk shows and say, no, this is really happening.
Do you mean the same thing could happen to us?
Yes, I believe it will. And just about every astronomer in the world believes it too. We have all read the same data.
So within a week or two, people will believe it. But the real question is, what will they do about it?
And when would this happen?
By our best calculations, 75 years. 75 years. The Earth will be destroyed. This is the end of Earth.
When people are faced with impending death, usually they go, one of two ways. They either bond together, right, in hopes of preserving humanity or at least preserving what is human, or they drop out and become hopeless. It would be incredibly important to create some kind of common goal. Some focal point that people could kind of bite into and own.
If nature throws something at us that is so utterly catastrophic that the Earth would be utterly destroyed, that would compel us, I think, to try to go elsewhere. You might think we could go to Mars, or maybe some of the moons of Jupiter as a place to escape what happens to the Earth. But in this scenario, essentially nowhere is going to be safe. There would be nothing left for us here. This means that our only real option would be to look for another solar system, to get completely away from this destroyed, decaying wreck of a system that we used to call home.
How could we possibly do that? Can we really get 7 billion people off the Earth and take them to some other place where we could survive as a race?
It's a tremendously costly thing to do. It would take an enormous number of resources, people, and enterprise to do this. But if you're faced with certain doom, it might be the one thing that you want to do.
There's a neutron star headed toward our solar system, and every second the clock is ticking down to the destruction of everything we've ever known. In 75 years, the neutron star will arrive, and it will destroy the Earth completely.
It boggles the mind. Can we really rescue 7 billion people? You have to remember, only about 600 people have ever gone into space in the entire history of the human race. Can we possibly move 7 billion people off of the Earth in a 75-year period? To be honest, I think we may have to face the likelihood that that won't be possible.
And then there's the problem of the distance that we're going to have to send them. We're probably going to have to go 6, 7, 8 light years at least, and that's 40 trillion miles.
One thing is pretty certain. We're not going to get there using the space vehicles that we have now.
The rockets that we know, Mercury, the Apollo, the space shuttle, these are all chemical rockets, and they're probably not going to do the trick.
It's just impossible to build a spacecraft to go to another star that uses chemical propellant. It's a cat chasing its tail kind of scenario, in that the more fuel that you put on to move the mass means you need yet more fuel to move the spacecraft. You just will never get there.
To make this work, we're going to have to build an absolutely colossal ship, and we're going to have to develop a new type of engine to propel it. The question is, can we?
We've got a lot to cover in a short time, so let's go ahead and get started. Here is E0302. The reason we're all here. It's a constant reminder that the clock is ticking. Today we'll be reviewing the initial proposals generated by our working groups in the Evacuation Vessel Division. I've been asked to remind everyone that this briefing, as well as this entire project, is classified.
Fortunately, nature gives us lots of ways to go to the stars, and most of these don't involve anything beyond known physics. But the engineering challenges are pretty tremendous.
Any plan to build a new space drive comes with great risks. But with the fate of humanity at stake, we're going to have to accept those risks, however great.
We've titled the project Horizon, and it represents the cutting edge in spacecraft propulsion technologies. We're going to be looking at a few approaches right now. Plasma. Promising, but it poses some real problems with regard to fuel and fuel storage, but this is a contender.
To make a rocket able to accelerate you to high speeds, the faster you can shoot the exhaust out, the better off you are. The idea of a plasma rocket is that we'll use electricity to accelerate our gas. And so then you can shoot things out to very large velocities.
But plasma, while it is more powerful, would probably require a lot of fuel. So really that puts us back to square one with the fuel problem.
Solar sails. This technology has the advantage of substantial research, especially in the last 15 years.
A solar sail derives its propulsion from sunlight. You can't feel it when you're out walking on a sunny day, but the light that's reflecting off of you is pushing on you.
There's a polymer fabric that we stretch over a wire frame. When the sail is in low orbit, it functions extremely effectively.
The solar intensity strikes the sail, and the momentum is transferred from the photons to the sail, propelling it along, much like the wind blows into a sail and pushes a ship.
And we've looked at designs of solar sails that, if they're large enough and lightweight enough, can get to very, very high speeds.
But the solar sail has an Achilles heel, and that is it receives its acceleration by radiation pressure from the sunlight from the sun. And as you get farther away from the sun, that radiation pressure gets weaker. The sunlight gets weaker as you move away. It's kind of like driving on a long, lonely highway and there's no gas station suddenly for many, many miles.
There's another candidate for an interstellar drive, and this one seems to come straight out of science fiction.
Antimatter. Antimatter is the fondest hope of every propulsion engineer for the last 2 decades.
Antimatter is kind of the mirror image of matter.
It has the same mass as a normal particle, like a proton, an electron, but it has different charge and spin. And what is really interesting is if you bring a matter particle and an antiparticle together, as soon as they interact, they annihilate each other, and this releases enormous amounts of energy.
They basically come together and turn into pure energy, and that's the equivalent of Einstein's E equals mc squared. It's 100% efficient. And there's no comparison between the antimatter energy storage per pound compared with fossil fuels that we're very familiar with. It's tens of thousands, if not hundreds of thousands times more energetic.
But antimatter presents serious challenges. All that energy is really, really dangerous, and we don't necessarily know how to control it, much less funnel it through an engine.
It's extremely unstable, and in the event of engine failure, it's catastrophic.
When we make it, we have to store it in a vacuum chamber and contain it in some very strong magnetic fields so that it doesn't interact with the walls of the chamber. Because if it does, it's going to annihilate and produce energy. And just in layman's terms, it becomes a very, very large bomb.
This is, to put it mildly, a long shot.
So here we are. We can't use chemical rockets. Solar cells eventually will run out of thrust, and antimatter is too dangerous. So that's pretty bad news for a vessel that's designed to travel to distant stars.
Thank you all for coming. We're going to break now and get into our discussion groups.
But we might have an ace up our sleeves. There's a technology that might work very well. The irony is that this technology is not new. It's over 60 years old, and it might just hold the answer.
Today, whatever you do, wherever you may go, you are a part of atomic warfare.
So during the Manhattan Project in the 1940s, there was a physicist. Stanislaw Ulam. And he proposed launching a massive space vehicle that was propelled by nuclear bombs.
A number of scientists, including Freeman Dyson, took this concept to the next level, imagining a spacecraft that would be propelled by nuclear explosions. And they called it Project Orion.
Orion is really very simple in concept. Imagine that you have a very large spacecraft, and on the back of it, you put big plates with big shock absorbers.
And what you do is you take nuclear bombs and you eject them from the spacecraft, and they go some distance behind, perhaps tens or hundreds of meters. They explode, and the blast wave hits this pressure plate. And you set off multiple of these detonations, so it's bang, 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 and the thing gradually starts to move along and accelerates up to a high velocity.
The pressure waves propel the spacecraft and move it forward. Orion would get you going really, really fast.
In the 1960s, Freeman Dyson and Ted Taylor built a working model of this concept using conventional explosives to propel the model up into the atmosphere. This experiment was called Putt-Putt, and it proved that you could propel a vehicle using conventional explosives. The fastest man-made object now is the Voyager probe, which is going at 0.006 times the speed of light. At that speed, it'll take it tens of thousands of years to reach another star. But with Project Orion, we can go much faster.
Studies that have been done show that if you were to detonate a bomb behind it once every 3 seconds for 10 days, you would get up to a significant fraction of the speed of light. The reason that the research really stopped were the nuclear test ban treaties.
We shall not regret that we have made this clear national commitment to the cause of man's survival.
Which were a good thing. They basically stopped us from setting off nuclear bombs in the atmosphere.
Theoretically, we could just pick up the research that's been done on the Orion system from when it was being conducted in the 60s.
To conceive and build such a vessel is going to take cooperation on a scale never before seen in the world.
We would need all of the technological and scientific expertise that we have in the world.
We're talking about natural resources. We're talking about economies of the world having to give up the concept of money, working toward a common good.
The problem is we have a set deadline. There is no leeway in this. We have to have it done in 75 years.
I think if people were to be faced with some kind of real threat to their existence, you'd see a lot of different kinds of reactions.
News. People have been taking
now with the emphasis on social media, it's going to be a huge impact that's going to spread out in a millisecond.
I think that you would have people who would look to religious groups and religious organizations for answers. I think you'd also see quite an increase in rates of suicide.
The world is going to end. There's going to be massive chaos.
The clock is ticking down. We have 70 years or less to evacuate the Earth and avoid being destroyed by the neutron star. And what we've decided is that we're essentially going to build an escape vessel, a lifeboat for the human race.
Once you decide you're going to design and build a starship, the first thing you need is to assemble the best minds on the planet who can do the work.
People from all different scientific backgrounds, biologists, botanists, physiologists, physicists. The list goes on and on of people who it would be necessary to have their cooperation.
And allowing a central location where these men and women can interact and coordinate their efforts, I think will be critical to the success of this endeavor.
it the Horizon Project. And we've been granted exclusive access to show you this sprawling compound as it arises from the soil here in Florida. They've already dubbed this complex Starship City. In a few months, this site will be secured by the military, and the fight to save humankind will begin.
You bring the community to Starship City. You bring all of your scientists and engineers there. And then you start to do design work. They need to have homes to live in. And it's not just them, it's their families, because they have wives or husbands and children which might come with them. And it becomes a massive community which needs supporting.
And they basically will be living at Starship City, if you will, for the duration of the production of this vehicle.
And they might be there essentially for the rest of their lives because this is a long-term project.
And this one upstart makeshift city is going to be the place where the entire future of the human race is to be determined.
Now, the first order of business at Starship City will be to figure out how to actually build the Orion and make it work.
Developing something like Orion is going to have several challenges. Well, the first thing you'll have to do is increase the production of plutonium. Because of the end of the Cold War, we haven't been building a lot more nuclear bombs, so we haven't been making it like we used to. And in fact, we don't make much of it at all these days. And so we'd have to do that. In addition to building up our supply of the plutonium fuel, you'd have to design the bomblets to be specifically used for Orion. You wouldn't be able to use decommissioned nuclear weapons from our arsenal, so you've got a whole new design effort for building these.
As you can see, the bomblets are going to be delivered to the pusher plate. One detonation every 3 seconds could get us to a respectable fraction of the speed of light, possibly even 7%.
So while we're perfecting the propulsion system, the next question will be, what exactly is it pushing? How big will it be? And what conditions will we need inside of it to prepare for the passengers?
One of the critical environmental elements that we're going to have to provide is one that we take for granted here on Earth, and that's gravity.
Gravity is an organizing principle for all large animals and plants, so we are structured in terms of our entire physiology and anatomy based on coping with gravity.
When you go into space, if you don't have gravity, one of the first things that starts to happen is that the bones in your body suffer calcium decay.
Your muscles start to atrophy. Other things happen to your physiology.
If you ever see guys that have come down from the International Space Station that have been in space for 3 months, when they get out of their capsule, they have to be supported. They literally will fall down. They're so weak.
Now we're talking about an entire lifetime spent in zero gravity. And so there's a whole host of problems. Number one will be the fact that I'm not sure if we can actually have men and women produce children in this environment. The reproductive system relies on gravity.
Every animal that has a bone system internally, that system would not evolve a proper way if it was done totally in a gravitational-free world. So if you were thinking about procreating in space, those offspring will have a difficult developmental time unless there's an artificial gravity that's created.
We don't even know what a body that grew in zero gravity from infancy or even from in the womb would look like. Would it operate like ours? Would it even be feasible to give birth in interstellar space? We have to assume that we will be raising at least several generations of humanity in space. And this is something that's never been done before.
Fortunately, there are fairly easy ways to simulate the effects of gravity, and one of those is through rotation.
Where you take the entire vehicle, slowly spin it around, and you create gravity through centrifugal force.
If you have a large cylinder that's slowly rotating, that force is pushing you to the outside edge of the cylinder. The centripetal acceleration to your body feels like gravity. And fortunately for us, that's good enough.
If a spinning cylinder is the way to go, then the question is, how big can we build it? Because that determines how many people we can fit inside. Well, the answer is pretty big. And this is where we can start talking about something called an O'Neill cylinder.
Gerard O'Neill is a professor of physics at Princeton University who postulated the design for a space colony where people would live on the inside surface of a rotating cylinder to produce artificial gravity.
This has all been simulated in computers, and we're fairly confident that this cylinder will maintain its pressure. In fact, over here we have the same type of pressure cylinder that O'Neill was theorizing would work in outer space. It's designed to hold an entire Earth's atmosphere worth of pressure inside it. And we'd have pressurized ports here that we could open up, and we could bring people and cargo in and out of the chamber. And then once it's sealed up, we know it's going to hold the amount of pressure we need.
Sounds good.
Light is another obvious issue. There's not much sunlight, even if you travel even just a few days away from the sun. So we're gonna need some artificial lighting, but that's not as big of a problem as you might think.
We could run a rod down the center of the ship, which would be like the sun according to a daily cycle, because humans and plants and other animals rely on the cycles of day and night for their rhythms of life, for their survival.
These rhythms dictate heart rate. They dictate body temperature. So maintaining a 24-hour cycle is critical to human health.
The idea is that you could build very large, self-contained habitats in space, that you could put an ecosystem inside, and that you could have hundreds of thousands, perhaps, people living there in space in a self-sufficient, self-contained spacecraft environment. It's something that is on the scale of what you would need to launch to the stars that a propulsion system like Orion might be able to propel.
They're calling it the Ark. It will be a cylinder, 15 miles long and 2 miles across. It's roughly 4 times the size of Manhattan.
Scientists at Starship City say that the ship may hold up to 250,000 people, but no scientist or government official is answering the next question, and that is, who gets to go?
There's a death sentence for planet Earth, an inescapable date with destruction. Humanity mounts a desperate effort to escape the only home we've ever known. We must build a vast ship and fly it to the stars. We must evacuate Earth. There's a bitter pill to swallow here, and that is we're never going to be able to build a ship or a set of ships that can transport 7 billion people off the Earth, and we certainly won't be able to do it in time. If that's the plan that we try, we're going to fail.
Luckily for humanity, we don't need everybody to go. A small, genetically diverse group can multiply once they reach the destination. The question then is, how do we choose that small group?
Who gets to go, to me, is the big question. How do we select the people who get to go on this escape trip, if you will?
One of the first things that we would want to do is screen the DNA of as many people as possible. We would like to ideally collect this from all over the planet, from the entire population, if it was feasible. What this would do is give us a snapshot of the human race at this point in time.
You're looking at essentially a founding group of people, human beings, on some distant planet. So the first thing you really want to consider is their survivability, which a genetic profile will at least give you a clue to.
Clearly, a key consideration is the biodiversity of the evacuees. We want to have a lot of genetic variability.
A population of people become very vulnerable when you have a monolithic genetic composition, very vulnerable to disease, very vulnerable to even sickness.
For example, if everybody was equally sensitive to an outburst of a flu or some kind of viral attack, then everybody potentially would die.
The scientific community would have to be directly involved in weeding out who is fit for this kind of project and also what kinds of people. The people that survive are going to have to be kind of biologically perfect in a way, as perfect as they could be, because we're talking about a survival over a long period of time.
One of the things that you really are looking for are people that have been relatively disease-free and have long life expectancies. You certainly don't want to have somebody on a spaceship who is diagnosed genetically as, for example, being a schizophrenic, or somebody that is a danger to the rest of the population on the spaceship. You don't want to have people that are diabetics. You don't want to have people that have other kinds of long-term health problems.
What we're doing is we're reducing the gene pool of the entire human race down to just the passengers on this one ship. So it's very important that we save as much genetic diversity as possible and that the people be as healthy as possible.
In some places, you would need trained medical personnel to collect the samples and do the screening. But in other cases, people might be able to send in the materials themselves. We could create an evacuation eligibility kit and mail it to as many people as possible. It would be a simple kit with a pin or swab stick, an instruction card, and a return envelope. And they all get shipped back to Starship City.
Once they get back to the laboratory, these samples will be screened.
How does this work? We can sequence the entire genome of any human being now for just a few $1,000s, amazingly enough. We could say that somebody has a risk factor for certain cancers. We know there are certain cancer genes. We know there are certain blood disease genes. We could screen for these diseases very, very easily. And the more genetic information we have in the next few years, the more we can screen for this. You would want people that are relatively genetically predisposed to surviving under different environments. If I were to choose people with long-term survival skills, with minimum amounts of resources, I would take Inuits from Greenland or northern Canada because they've lived in very, very harsh environments for thousands of years. Those kinds of survival skills are very, very, very critical.
Genetics aren't the only criteria for getting into this group. There are certain skill sets that will be required. First of all, you need a crew to fly the ship and to maintain all of its various subsystems. Doctors, engineers, pilots, scientists, medical technicians, medical researchers, although we'll probably make those determinations further down the road.
No matter what criteria is selected, once you start deciding who gets to go, you're deciding who doesn't go. And that is a lot of people. In fact, it's 99% of the people who are not going to get to go. And no matter how objective you are in choosing your criteria, there's going to be many people who are going to see the selection process as being biased in favor of the powerful.
Wealthy elites would largely shape the priorities in this endeavor and would be involved very closely in selecting who would be the group of survivors that would actually make it into space.
We know that those in power are going to be writing the rules of who gets to go. They're going to have the brain power, they're going to have the financial expertise.
Protests have erupted in 71 different countries on 5 continents today. The protesters calling for the Starship program to be shut down. Why? Some say it's too much of an economic drain. Others say the selection of the evacuees is biased.
There are going to be lots of nations, lots of countries around the world with very few people selected to go on this journey.
There will be populations of people who are already resource poor, who will want to be part of this project but won't be selected. And the struggle for resources is usually a violent one. There's a lot of room for tragedy.
Unless the world at large and the people in the world were feeling that they were getting some kind of chance to get on this ship, they wouldn't put up with any other strategy.
What's fair with regard to percentage of population? What's fair with regard to the countries that have donated the most resources to the project? If there are nations who have decided we don't want to have anything to do with this, do we allow individuals from their countries to join us on this journey?
You could just have a simple lottery in which anyone had an equal chance of getting into that, but it would be extremely messy, and wars could well break out over who would get on that ship.
Regimes might say, like, you know what? I have a nuclear bomb. If you don't do as I say, the world is going to end. The times are ending. It's time to move on and do it now.
One of the things that I think is likely to erupt is that we will see increased prevalence of civil war. And people in power could choose to just leave those civil wars alone and not intervene and allow people and communities of people to self-destruct and kill each other off.
So you have 2 different scenarios. One that, you know, people are going to get together and have the best of humanity. On the other hand, it might be the worst of humanity.
How will people react that are not selected for this journey? Will they do whatever they can to ensure that no one gets to go? Will they try to sabotage this attempt to save humanity?
In threat of a catastrophe of this magnitude, I think that there would be a real risk of kind of a formation of cults or fundamentalist groups that would want to sabotage such a project.
You have entered a restricted area. Stop your vehicle now.
There are certainly stories in the Bible and in other religions about humanity being wiped out periodically throughout human history. Some will see this as another sign of that type of event. And so we're going to have to protect against those who want to sabotage this journey.
The Starship City perimeter has been armed with landmines. Your vehicle will be destroyed. You have entered a restricted area. Stop your vehicle now. Starship City perimeter has been armed with landmines. Your vehicle will be destroyed.
According to a spokeswoman for the Horizon Project, damage from over 30 terrorist attacks has caused grave delays to the program, which is already struggling against a tight deadline.
The Horizon Project suffered a new kind of setback today when 45 scientists working in Starship City left for what can only be described as the competition. Another evacuation ship has been secretly developed by a consortium of super wealthy individuals looking for their own ticket off the planet.
It's entirely possible that in addition to this national effort to build a space ark, that there might be multiple space arks being built by private individuals. There's no reason it couldn't happen. It's just money.
What you might have is some of the very rich people like Bill Gates and Richard Branson, who already own multi-billion-dollar companies, may decide to come together and try and build their own spacecraft.
And now we continue our conversation with billionaire technologist William Jeffers. Doesn't a lifeboat full of billionaires seem like an insult to humanity's survival?
Well, Katie, I look at it differently. Why should the government decide who evacuates the Earth? Now, this evacuation is going to be a huge undertaking. The resources of successful individuals are going to build that ship, which we've named Savior 1. Why shouldn't they be allowed to get on it?
There's a growing effort in commercial space by private individuals who want to see space developed. A lot of people don't realize that a lot of the rocket launches that happen every year are not NASA rockets.
The cost for a single ticket on your evacuation ships is $500 million.
When you consider the cost of doing what we envision doing, that's a bargain.
Once we know that our system is doomed, we have to begin looking for other solar systems with planets that could support us.
We believe there must be other planets out there like ours. This was something that was only a philosophical statement 20 years ago. Now we suspect that there are many places like the Earth out there. The only question is when we'll find them and how close the nearest one will be.
Finding another planet won't be easy, but we already have telescopes in space looking for Earth-like planets orbiting other stars.
The most prolific one right now is the Kepler Space Telescope. Kepler is a 1-meter space telescope in an Earth trailing orbit. And Kepler looks at 150,000 stars every 6 seconds and looks for a tiny drop in brightness when the planet goes in front of the star.
That dip in the light intensity is essentially a very small eclipse.
Every so often, by chance, a planet may pass between us and its parent star. In doing so, it blocks a tiny bit of the light from that star. If we monitor the star, we can actually see that change in light coming from the star, and it tells us that there is a planet there.
Kepler now has 2,000 candidate planets. It has planets that are the size of the Earth and smaller.
That's potentially a lot of new homes, but the problem is that Kepler's targets are very far away.
Kepler targets are at distances of 1,000 to 1,500 light years, so while this is a great experiment for giving us the odds of finding something, it's not a great experiment for finding where nearby we could go.
Finding a planet nearby is essential. The longer that we spend on the spaceship, the more that can go wrong, and the more danger and threat there is to the survival of the species.
And of course, the real golden nugget at the end of this search, of course, is to find an Earth-like world in what's called the Goldilocks zone.
The Goldilocks zone refers to a zone around a star where the temperature is just right for liquid water at the surface of the planet.
Liquid water is a critical piece of biology. It's an important part of the chemistry of life itself.
The next thing we need is the composition of the atmosphere.
If we see molecules like oxygen and methane in an atmosphere based on the template of the Earth, that would be a real fingerprint for the existence of life on that planet, because both molecules together are very reactive and will not survive for long unless something is replenishing them. On Earth, the things that replenish those molecules are organisms.
And even if we did find a planet that was in the habitable zone of its parent star, it had the right temperature, it had the right surface gravity, and maybe even a thriving biosphere, there's still going to be a lot of unknowns that could kill any newcomer.
One big one, for example, is wind speed. You know, as humans, we can barely function in 50-mile-per-hour winds. Some planets may have winds upwards of 200 miles per hour all the time.
We could get there and discover that the things we thought pointed towards a nice temperate environment are actually wrong. Maybe it's a planet of crazy chemistry and strange volcanism that's completely uninhabitable.
I would be personally concerned that we get to the planet and there are poisonous gases that we're not aware of. So really knowing the composition of the planet in a lot of detail is not going to be possible until we get there.
The very best thing we can hope to do from a distance is to make an informed guess about which planets may or may not harbor life, may or may not have an environment that would be suitable for us.
At some point, we're basically going to have to take what amounts to a massive gamble.
So that's it. Does anybody have any reservations about recommending this?
We're just going to have to trust our instruments, trust our measurements, and just select the location and just go.
This is the best chance. Nothing else even comes close.
Because in this situation, there's going to be no time to go back and forth on our decision making. The human race cannot die due to paralysis of analysis.
Scientists at Starship City are celebrating today. They have found humanity's next home. The planet has oxygen in its atmosphere, and researchers believe there's already plant life. It's circling a sun known as Barnard's star, a little less than 6 light years away, which means it would take about 80 to 100 years to get there by present calculations. Its name is Barnard C352, but researchers have already renamed it Earth 2.
As the neutron star comes into the system, matter, bits of rock, asteroid, comet, you name it, in our solar system will be attracted to that object. But as they hit the surface of the neutron star, it's like setting off nuclear bombs. So this object is going to begin to pump out radiation, which is going to scorch everything in its path.
So we can find ourselves in a situation where as this neutron star approaches us, the radiation from the neutron star would be digging through the Earth's atmosphere and digging a hole in the atmosphere. And if we find ourselves in this case where the beam coming from the neutron star sweep by the planet Earth, God help us. As the neutron star gets closer and the radiation from the neutron star begins to affect the Earth's atmosphere, it's going to essentially open up holes in our atmosphere that's going to allow deadly radiation from space to come in. Anyone who wants to survive this time period will have to have ready access to shelter, and preferably deep underground.
As the neutron star gets closer and more calamities happen, there's going to be a growing disparity in the quality of life between people in the industrialized world and people elsewhere, where nobody's looking out for them and providing shelters and things like that. They're going to pull them through this.
Millions are dead as radiation from the neutron star bombarded the Western Hemisphere yesterday.
Experts say direct exposure to the radiation was worse than the radiation at ground zero of the Hiroshima bomb.
Loss of plants and livestock are expected to lead to global food shortages. For many skeptics, this is finally proof that Earth is really dying.
Even with this radiation raining down on us, we're not going to be able to let up on our construction effort for even a moment. The very survival of our species depends on it.
Most people think of launching a spaceship as a rocket that goes up in one piece and reaches orbit. Well, for something as big as this, that's not going to work. But luckily, there are other ways to build a spaceship. It really makes a lot more sense to put it together in pieces and parts and launch those into space and assemble them there.
On the ground, you're subjected to the forces of weather. You have the Earth's gravity. When you launch something on a rocket to go to space, you're traveling through the atmosphere. You've got the atmospheric pressures. You've got the wind dynamics. You've got all these stresses on it. When you get out into space where you don't have weather, you don't have the Earth's gravity, you don't have to put as much mass and waste time designing it for two environments. The environment for transit through the atmosphere and then space. You just can concentrate on what it's going to take to keep it in space.
The idea of building something so complex and so enormous in space might come across as a bit overwhelming, but the truth is, we've already done something like this.
We have experience taking modules and components built in the United States, built in Russia, built in Japan, built in Europe, launching them on several different types of rockets, getting them in the same orbit so they can do a rendezvous together, and actually assemble them in space to form the International Space Station, the ISS, which is up there now.
That's one of the useful things of the International Space Station. It's given us the knowledge of how to assemble structures in orbit.
Is it a challenge? Well, certainly. We have done it once before. Not on this scale.
We probably won't be able to build the entire ship at Starship City. What we're going to have to do is we're going to have to distribute the manufacturing all around the world, creating what is essentially a global assembly line. And that probably is the only chance we have of meeting our deadline. And this would not just be a few hundred pieces.
其中有23个工厂在中国。
We're talking millions of pieces. But even now, there's places on Earth that can do this. In the United States, Russia, Japan, Europe, India, all of the spacefaring countries in the world could do this.
从那儿，他们将被送到天体运行轨道进行安装。
The biggest challenge is going to be the systems engineering, putting the logistics together and getting all the pieces to fit. Something of this scale and this scope is going to require multiple manufacturing facilities on the ground, probably in many countries. They're going to have to use different tooling and different engineering processes, and they have to make sure that once they get into space, tab A fits into part B and everything connects and works properly. The last thing you want to do is find out that your pieces don't fit together properly when you get to space.
Launching all these pieces of spacecraft into orbit is going to be a challenge, but it's doable. Even now, we're building rockets that are able to lift as much as 130 tons into low Earth orbit. That means you can take up pretty big chunks of this thing at each launch. Now, even if we are able to get these pieces up into orbit for assembly, the real work is just beginning. There's all sorts of challenges up there in space that's going to make this a very perilous operation right to the end.
This is the latest report from Starship City. In spite of recent setbacks, projections indicate that the Ark might be finished on time.
With over 150 launches a week, the Horizon project is sending more than 4,000 tons of supplies, instruments, and parts to the giant ship.
At 15 miles long and 2 miles wide, the ship still requires millions of tons of soil and millions of gallons of water. And all supplies need to be carried to orbit, 260 miles above the Earth.
Launching the sections of this ship into space, that's the easy part. We've done that before. But even with the most advanced robotics that we have, assembling those things into a starship is something that's going to require human coordination of a huge scale.
The hardest part is going to be the coordination and the actual assembly in space. I personally don't believe we'd be able to assemble our spaceship just totally robotically without people.
That is absolutely gorgeous. 0G and I feel fine.
You can do a lot robotically, but sometimes you just got to have a person on site to make things work. But you'll probably have to have somewhere on the craft astronauts outside in spacesuits 24/7, overseeing the construction, doing repairs and maintenance as the spacecraft's coming together.
And that could be a very dangerous situation because we have space junk flying around the Earth at high speed.
In the history of space exploration, we haven't been as neat and tidy with our spacecraft as we should have been.
First pair and second pair both have successfully jettisoned the vehicle. Everything is looking good.
And there have been cases where rockets have exploded and scattered hundreds of pieces of debris into orbit. We've had spacecraft that have failed, and even a couple that have run into each other and shattered into many hundreds, if not thousands, of pieces.
And this problem could be made worse by the Starship effort itself.
If we're making 1,000 times as many launches in a period of a few years to build this, we could have a lot of old rocket stages flying around at high speed.
These pieces are moving at orbital speeds, which is on the order of about 5 to 6 or even 7 miles a second. And that's faster than any bullet you can fire on the ground. And would do tremendous damage if it hit you.
As we build this spacecraft, we'll have to keep track of junk in space, old debris that's incoming from different directions. We'll have to think of ways to prevent all this stuff from colliding with or damaging our equipment. This is another place where we're going to have to factor in failure.
Up to this point, we've been suffering through the secondary effects of the neutron star, the radiation, projectiles, but now, as a neutron star nears the edge of our solar system, that's the beginning of the end.
We could alter our orbit. Our orbit could become more elliptical. This would mean that our experience of seasons would become radically different.
Now, we are looking at another day of extreme weather, folks. Los Angeles, you guys will be wrestling with another bout of chill, 50 degrees below zero.
There would be vastly greater difference between winter and summer on a level that we won't get from just global warming or changes like that are occurring.
We are talking about a 140-degree heat wave moving in on Manitoba. Keep your water supplies covered. It's very important for you to go into your basement in the middle of the day.
And we're out.
It's human nature to fight for survival, so there will undoubtedly be other groups of people who will build their own ships and try to ensure their own survival. And some of those smaller groups might actually finish their projects before we do.
It's less than 20 minutes now before Savior 1, the evacuation ship created by the late billionaire Bill Jeffers Sr., will launch.
The list of 512 evacuees on board reads like a who's who of the super wealthy and globally famous. They're traveling with 72 scientists and engineers who earned places on the ship along with their families by helping to construct it.
We have an exclusive link to the flight deck, where Bill Jeffers Jr. is himself one of the co-pilots. We spoke with him earlier during his pre-launch preparations. Mr. Jeffers, an exciting moment for us all. Would you agree?
Well, that's right. My dad found the funding that no one thought we could find, and we developed the world's first antimatter engine when everyone said it was too dangerous. So, from everyone on board, we want to say that there's always hope if you believe you can accomplish the impossible.
Savior 1. I'm just waiting on the go for final countdown, and we'll release the hull. We're on the automatic sequence. Let's start the countdown.
5, 4, 3, 2, 1. We have ignition failure. Repeat, ignition failure.
We have an engine malfunction. We are in abort-ready mode. Repeat, abort-ready mode. All crew and passengers prepare for emergency evacuation.
We're on the automatic sequence. Let's start the countdown.
5, 4, 3, 2, 1. We have ignition failure. Repeat, ignition failure.
I don't know, we've lost flow.
We have engine malfunction. We have an engine malfunction.
3 and 4, master.
All crew and passengers prepare for emergency evacuation.
2 coming up.
We have breaking news from the launch site of the Savior 1. About 5 minutes ago, precisely at the time of the scheduled launch, there was a horrific explosion.
Critics are already insisting that Savior 1's ambitious antimatter propulsion system was a disaster waiting to happen.
The thing you have to remember about storing antimatter is it can't come into contact with any matter. So you need to pump all the air out of your container, and you need to put a magnetic field in there in order to trap these charged particles so that they don't touch the sides of the container. A storage failure, in this case, is basically a big explosion.
Now, the telemetry is still coming in, and the investigation is still ongoing, but it does seem that the ignition chamber was properly fueled for launch. The problem came when the first ignition attempt failed. The onboard computer released a second load of antimatter into the chamber. That was twice the charge, so when the ignition did fire, the containment housing couldn't hold it, and it caused a crack in the vacuum seal, and that's what allowed air into the chamber. We all know what happened.
At this point, everything, our history, our art, our science, our very existence, depends on those few human beings who are preparing the Ark ship for a century of human habitation. and there's only a handful of years left to get it right.
Remember, this ark has to sustain the lives of every survivor in the human race. So it's going to need to be supplied with everything they're going to need for decades on their journey.
Air, water, food. If we don't have those things, we're not going to make it, period. But fortunately, the first two, air and water, are essentially the same thing, scientifically speaking.
You can make oxygen easily by just putting an electrical current through water, which is essentially what organisms do when they generate oxygen from photosynthesis. And if you have a nuclear power plant on a spaceship, you can generate electricity for a very, very long period of time, safely, and you can just hydrolyze the water to generate oxygen.
So we can breathe, and we have water. Now we have to figure out our food supply. As mundane as it seems, we've never done anything on this scale before, and certainly not in space. And every man, woman, and child on the ship stands a chance of dying if we don't figure it out.
How do we feed 250,000 people for this duration of time? We certainly cannot take all of our food with us.
You obviously can't take millions of cans of baked beans and frozen chicken burgers all the way to the stars. That's not viable.
You can't have a supply of food that gets depleted over time. It has to be able to replenish itself without depending on supplies coming in from the outside.
You will not be eating meat in space. No steak in space. You can have a meat-flavored material, but you will not be eating meat in space. And the reason for that is very, very, very simple. The conversion of vegetable material to animal muscle, there's only a 10% conversion efficiency. In other words, in 1 pound of steak, the cow consumed roughly 10 pounds of grass. If you really are hungry for animal protein, you can get some good worms or some roaches. Insects have been a source of protein for humans for a long time.
The idea is that there would be some agriculture. But who knows? Maybe we'll come to enjoy insects and that kind of thing.
We have to consider growing crops. We certainly have to come up with new crops that are resistant to the radiation sources that will certainly be out there in space. We're going to have to come up with new seeds that are impervious, perhaps, to the microgravity environment.
Growing corn in space is not a viable option here. You're going to be growing algae. You're going to be eating chlorella crackers, little green, thin wafers that'll taste like dried spinach on a good day.
We have large areas with crop growth. That is most likely going to create its own environment and its own weather within the vehicle. And so now are we talking about rain falling within the vehicle? We certainly can't predict what will happen in 60, 80 years during this journey. So all these technologies we'll have to test here on Earth.
The question of diet raises the importance of bringing along a few trillion more passengers on board. We're talking about bacteria.
It's critical that we would take a complement of microbes into space. It's absolutely essential for the survival of human life.
6 pounds of a typical human adult's weight is microorganisms. Without bacteria, we wouldn't even be able to perform simple functions like digesting our food.
Those organisms all evolved more than 2.5 billion years ago on this planet. They are the ones that made the planet habitable for all the other creatures on it.
One big advantage to bacteria is that they travel well.
To take bacteria in space is quite easy, actually. You can take bacteria in very, very small vials, and they're stored in liquid nitrogen or some other very, very cold fluid. It's just like storing sperm in a sperm bank.
The thing you have to remember is that all of these programs have to take place at the same time. Building the ship, selecting a destination, solving supply problems, figuring out how to feed the evacuees. It all has to be simultaneously coordinated, or it's not going to get done. The neutron star isn't going to give us an extension.
As the end draws near, we'll begin to see signs of our ultimate fate. When the neutron star reaches the outer planets of our solar system, that's when the fireworks really begin.
It's beginning. Look. The F ring is going to go first, and then the A ring, and then Cassini. Beginning. Look. The F ring is going to go first, and then the A ring, and then Cassini.
Just gone.
And we're next.
Now, humanity's only hope lies with the Horizon Project's Space Ark.
Shuttlecrafts will transport the evacuees to the ship in orbit.
We've got our tens of thousands of individuals, and we've got their food and water and air to breathe.
At this point, I think we would definitely want to board our craft. We're going to want to leave the planet.
It'll be an interesting challenge to keep the passengers and crew positive, especially in the early going.
Today, after 6 months of technical and physical fitness training, the civilian men and women who have been chosen to leave the planet are now getting ready to evacuate Earth. Today will be their last chance to say goodbye to their friends and loved ones they'll soon leave behind.
The people that start off on the mission, possibly they're going to suffer from depression because the realization that their home world has been destroyed.
There will be friends, loved ones, places left behind, never to be seen again, and that's got to hurt everyone.
We're so lucky to be one of the few thousand intact families going.
How could we not do it? It's the only choice we have.
Once they pass through those doors, they'll be processed for boarding. Then a final medical examination before making their way onto one of 100 launch shuttles that will take them to the Ark ship.
For the first time, humans will be leaving their home. They'll be traveling for 60, 80, 100 years perhaps, in a large vessel with 250,000 people aboard. They've left behind perhaps family members. They've left behind places they grew up. I think it's very important that we maintain a family structure during this journey, that we allow individuals to form a home, if you will.
The Ark ship's piloting crew has already been on board for weeks awaiting the passengers, who will acclimate 6 to 18 months before the ship departs.
If we pull it off, the Ark ship is going to be a wonder unlike anything humans have ever created. The last wonder we'll ever create on Earth.
on their assumption that people are going to behave. But we have to be certain that we have some laws, that we have some rules, that we have a structure. I think what would worry me the most is just the social cohesion of the group. Will they stay on task, or will they rebel and try to do something different, to turn the ship around, to give up, keeping people directed towards their goal all that time, not breaking up into factions on board the ship, not killing each other. The same problem we have in a city or in adjacent countries. That's what we've got to master.
Clearly, we will have individuals from multiple countries. Who's to say that the hatred and the problems that we have here on Earth will not befall us on this journey? We have to be very careful to avoid cliques or groups of individuals who are separating themselves from the rest of the population. Think of a high school clique that you may have been in. So I think one of the key considerations will be to try to minimize these cliques and these subgroup formations during the journey.
The obvious thing you need is governance. What's the laws that you take with you? Is it the Constitution of the United States? Is it the United Nations? What kind of political structure do you have on board? Do you want a democracy? This is a really interesting question, because you certainly don't want a dictator who's going to just rule everyone, and he gets there and he's going to be the rule of the planet and never step down. But at the same time, you need some kind of military structure that makes sure the orders are executed, because the people in charge are making very hard decisions in a military-like way. But if there was a democracy, perhaps they would be outvoted as being the person that makes the decisions, and this could actually affect the success of the mission.
There would always be the danger that it could totally degenerate into chaos. But chances are, if we had enough smarts to build a ship, to select people to get onto the ship, those people would figure out equitable ways of dealing with life's issues in that situation. But the most important thing is getting the human species, enough of the human species, off this planet out into space to survive.
As a neutron star approaches the Earth, there are two things that are going to happen.
The internal core and the crust of the Earth would start to get heated up, and it would start to become molten, and this would result in earthquakes on a scale that we've never seen.
What will happen next is the neutron star's gravitational field will begin to tear away our planet.
Once the Earth's atmosphere, the Earth's oceans, and the Earth's crust start to become perturbed, it's going to kill people pretty quickly.
Then I think the Earth's crust will shatter. The hot interior of the planet will essentially spill out into the vacuum of space.
By the time the neutron star literally rips the Earth to pieces, everybody on the Earth is already going to be dead from radiation or volcanism or any number of other things. So there won't be anybody there to witness this event, except for the people, of course, on the Ark.
The material of a shredded Earth can do a couple of things. It may fall straight onto the neutron star and result in colossal explosions. It's also possible that it would enter into an orbit around the neutron star as a ring. So in fact, our planet could become a ring system.
Who's going to be there when we arrive?
The human life expectancy currently is about 70 years. So by the time we reach the distant planet that is our target, chances are most of the original people who got on the Ark ship aren't going to be around.
Clearly, those who were in their 50s and 60s when the journey began won't make it. Most likely to be the younger children.
You can imagine that being a very emotional experience because they know they've reached the end of their long journey and they were successful, but in some ways they've only started it.
Imagine the flood of emotions that these people are going to feel the first time they see the surface of this planet. But now they're tasked with doing something that's even more immense. Now they have to go down to this planet and rebuild human civilization on a new world.
A lot of people would say that thinking about building an interstellar ark and evacuating the planet is kind of a waste of time. I'm not sure that it's something we want to put a lot of effort into without a threat, but it's certainly something we need to be thinking about because sometime in the future, it's inevitable that we're going to want to leave the planet. Hopefully, without being forced to by a catastrophe.
This is a crazy thing to think about. It seems like science fiction. The end of the world, no going back, we have to escape, we have to evacuate Earth. But it's really impossible to say that it will never happen. And it's also interesting to think about because it's a question of whether we as a species will ever expand beyond the confines of the planet that gave birth to us. If you look at evolution on Earth, often great migrations and expansions of particular species are initiated because of some disaster that forces that species to move on. We may be the same. It may be that an event like this, as devastating as it is the one thing that ensures that our species will live forever as it propagates out into the universe. System.
If we determined that a neutron star was really headed in our direction, that's very bad news. You can't blow it up, you can't change its direction, you can get out of its way, or you can suffer the horrendous consequences of being destroyed by a neutron star.
Some scientists are calling it the end of the world.
It's called a neutron star, and astronomers think it's on a collision course with Earth.
If you're just joining us, we're talking with the University of Oklahoma astrophysicist Lawrence Kellogg. Dr. Kellogg, this whole scenario sounds like something out of a movie.
Yes, I suppose it does, but I assure you it's real.
Probably the first public response to a report that there was a doomsday device heading towards Earth is people would think, oh, well, Spielberg's making a new movie. This is probably some kind of gimmick he's doing to get everybody interested.
Where does this neutron star come from?
Some 60,000 years ago, a star at the edge of our galaxy collapsed in a huge explosion. We call it a supernova. Now, the violence of this event catapulted the dead remnants on a journey of thousands of years. Along its way, it is causing cataclysmic damage to anything it encounters.
One of the problems with our current age, which can be a good thing depending upon what the issue is or a bad thing, is that people are very cynical. We don't particularly believe what we see and hear. And you can imagine you'd have various people, various scientists get on the talk shows and say, no, this is really happening.
Do you mean the same thing could happen to us?
Yes, I believe it will. And just about every astronomer in the world believes it too. We have all read the same data.
So within a week or two, people will believe it. But the real question is, what will they do about it?
And when would this happen?
By our best calculations, 75 years. 75 years. The Earth will be destroyed. This is the end of Earth.
You destroy it forever. These objects could fling comets and asteroids towards us well before they actually reach anywhere close to where we are. So based on all of these unprecedented meteor showers, we would then turn our telescopes in that direction and look intensely to see what was there. We might begin to see, for example, a rogue object from somewhere else, from intergalactic space. One of the most extreme possibilities we can think of would involve an object that we call a neutron star.
A neutron star is a stellar corpse. A star much more massive than the sun burns through its fuel extremely rapidly. And at the end of its life, when it runs out of fuel, the entire core of the star simply collapses.
This creates one type of supernova in a massive stellar explosion.
But what's left behind is this incredibly dense core made of neutrons. It's something like 10 kilometers across.
Because a neutron star is the mass of 2 or 3 suns, its gravitational pull is enormously strong. And that means that as objects get closer to it, they're subject to enormously powerful forces that can tear them apart.
The other really scary thing about a neutron star is that when it collapses on itself, it can shoot itself off into space at a very high velocity.
It can actually be sent hurtling through space at incredible speeds. So beware anything that gets in its path.
As the neutron star nears our solar system, its intense gravitational field will disturb the orbits of objects like asteroids, and some of that material may arrive as a deadly hail of meteorites right here.
What would happen next? The first thing that the scientists would do is to try to model potential scenarios for the path of this thing into us.
When people are faced with impending death, usually they go, one of two ways. They either bond together, right, in hopes of preserving humanity, or at least preserving what is human, or they drop out and become hopeless. It would be incredibly important to create some kind of common goal. Some focal point that people could kind of bite into and own.
If nature throws something at us that is so utterly catastrophic that the Earth would be utterly destroyed, that would compel us, I think, to try to go elsewhere. might think we could go to Mars, or maybe some of the moons of Jupiter as a place to escape what happens to the Earth. But in this scenario, essentially nowhere is going to be safe. There would be nothing left for us here. This means that our only real option would be to look for another solar system, to get completely away from this destroyed, decaying wreck of a system that we used to call home.
How could we possibly do that? Can we really get 7 billion people off the Earth and take them to some other place where we could survive as a race?
It's a tremendously costly thing to do. It would take an enormous number of resources, people, and enterprise to do this. But if you're faced with certain doom, it might be the one thing that you want to do.
Is doomed. A devastating force is coming, and we're running out of time. As civilization crumbles around us and our planet is destroyed, can we build spacecraft to take us to new habitable worlds? Can humankind escape annihilation? Can we evacuate Earth?
It seems like science fiction. The end of the world, no going back, we have to escape, we have to evacuate Earth. But it's really impossible to say that it will never happen.
We have this view of stability on the planet Earth because it's existed for several billions of years, and we've evolved on a reasonably stable environment.
We have small catastrophes all the time, like hurricanes, tornadoes, earthquakes, but in general, the human population continues to grow. This gives us perhaps a false impression about the future.
별 보는 거 좋아하지?
아빠, 여기?
그래, 여기. 잠시 한번 볼래? 잘 보이니?
All of human life, human civilization, and all the other life on this planet really exists in a tiny, precarious shell on this rocky object going around a star in the middle of a big and lonely galaxy.
Is that a shooting star?
Oh, wow, yeah, look at that one.
The ups and downs that we've experienced as a species are nothing compared to what the universe can throw at us. Now, there's a whole list of bad things that can happen to a planet like the Earth.
¿Eso está pasando ahora?
Sí.
Vamos.
There are scenarios where our planet, the Earth, could be completely destroyed.
¡Abran el domo! ¡Abran el domo!
Get in the truck. Get in the truck. Get in the truck.
Reports out of cities from Tucson, Arizona to Okayama, Japan describe meteors the size of bowling balls raining down untold destruction.
Authorities estimate the death toll at 250,000 and rising. This could be the worst natural disaster the world has ever known.
Some leading scientists are now suggesting this deadly event may only be the tip of the iceberg, a signal that the destruction of our world is rapidly approaching.
If we were suddenly bombarded with a shower of large objects from space, that would be catastrophic for Earth, and it would mean many different things, but none of them are good.
Now, there are objects out in the universe that would make the Earth utterly uninhabitable, or possibly